Welcome to Podomation, where we talk about all things automation and industrial cybersecurity. Podomation is brought to you by ISA, the International Society of Automation.
Good day and welcome down under to ISA's next episode of Podomation, which will be on deep water production to the moon to Mars mission, Australia's robotics and digital twin global impact. I'm Morgan Ford and I will be your host today. I'm here with Peter Jackson, James Sheridan, and David Dickson. Thank you so much for joining us, guys. What we really want to talk about today is as the world starts to think about how new technology and sustainability conversations impact their business, where's Australia in the process? Robotics and digital twins have made an impact on these major global issues here in Australia. And today we are inside an Igloo immersive space, which is a giant VR headset showcasing advancements in these technologies. Our experts will reflect on them, how they position Australia, and how to keep new technology cyber safe. With that, let's meet the panelists.
Hi everyone, my name is James Sheridan. I'm the head of Asia Pacific for IglooVision, but I have a background in all of our software and engineering projects, and I've worked a lot in oil and gas, energy, construction projects as well. And so yeah, happy to be here.
G'day, it's Peter Jackson from SGS ECL. I'm an industrial cybersecurity practitioner. I lead a team of SGS ECL consultants and engineers with a control system background. I'm also a SANS instructor for the ICS 515, and yeah, really happy to be here.
Fantastic. Thanks so much, guys. Let's start the conversation off today with Igloo. James, thank you for hosting at your customers Igloo in Western Australia. Please walk us through the technology here and how it's utilized.
Yeah, so what we're in is an Igloo immersive space. It's a 5-meter cylinder with floor projection, and it gets used a lot as a digital twin. And it started off as a training environment. So it was there for getting people up to speed on a new facility. And so some of the platforms that our client here in Perth is building are offshore and they're automated. So there's no one that lives there. There is no kind of berths for people to stay and service it. And so how do people, when they get there, know what they're doing? And so as a way of training those people up, they use a virtual version of it. But what's actually happened is instead of just doing digital twin stuff like this, where it's based on photography, they've decided to use it in the construction process as well. And so we've gone from something like this, where it's like street view and we're jumping on a platform. And let me show you another one, where we can jump to different locations on the platform and talk about it, to also looking at the digital twin version of that, so the construction version. And so it's great to be able to show people around and to get their wayfinding and navigation abilities. But what people are doing these days is doing design reviews and construction stuff as well. And so that goes from the digital twin version, which I can show you in a little bit, but also things like a sub and crane simulator. So let me just show you that. So what we have here is a system from the Ocean Simulation Center, and you can see here we have we're out in the ocean, and we have the boat here with the crane, and you can see I can fly around this, but I can also jump into the crane and start to move the crane around. I can jump down into the submarine and start to fly the submarine. And so here I can take off. And you'll see here my little robot arm moving around. And so the idea is that people practice the whole simulation. So the idea when they first started this was the design of the facility and how to make it accessible, how to make it serviceable, how to make it functional, and then training people how to use it. But now the way things have grown is looking at the whole life cycle of that process. So not just, all right, once it's installed, how to use it, but how do we set it up? How do we deploy it? And so being able to look at the go, no-go conditions, if the water's too wavy, to look at the building process, sending a camera over to a remote location where the platform's being built and getting that checked off. And then once it's done, all the facilities management side of that as well. And so how to actually repair the facility, how to do maintenance on the facility, emergency procedures and all that sort of stuff as well.
Well, James, I mentioned that this is like a virtual reality headset, but what makes it different? What makes Igloo special?
Yeah, sure. Let me just bring some of this up. And I think the big difference on something like this is that you can use things like a crane simulator chair. But the other things that are really, really different is body language and eye contact. So we did a heap of studies with one of the universities over in England. And for a facility like this, they looked at the difference between a VR headset, a monitor, and a shared VR space like this. And it was looking at navigation tasks. So like, all right, where is the fire extinguisher? How do I find the radio button if there's an emergency? And there was no real quantitative difference in learning for that memory task. The huge difference, though, was from the person doing the training. And for them, when they felt really safe in signing someone off to know a plan like this, they thought that the shared immersive space was the nicest by far. And that was because when they look at each other in the eye and body language, if I ask you to explain what this pipe is, or maybe where that cable run over there goes, then for that, if you look up and to the left or how you carry yourself, and if you start to look around like you're not sure what's going on, was a big teller for the person doing the training. And they found that not only did the training and those sessions of signing someone off go a lot quicker when they had a kind of that shared body language and conversation, they felt a lot more confident that the person knew what they were talking about.
That's a really good point. So with that, during COVID, people were forced to embrace technology like this to allow more remote collaboration. Now that it's post-COVID, organizations are being driven to achieve together sustainability goals. How does Igloo contribute to sustainability goals?
Yeah, so as I mentioned before, they're doing some of the factory acceptance testing for platforms like this one. So this one is I guess a moored platform, but the platform that they're using here is going to be a floating platform. So it's being built over in another country. And instead of flying over heaps of experts to do that factory acceptance testing all the time, what they do is they send a 360 camera. And that 360 camera takes them to that site and they can do a tour around the site. And I'll jump to one here. Here we are at Lucas Heights reactor. And so this is a public video, which I've just grabbed off YouTube, but it shows the same concept that the energy and oil and gas clients are using it for. And that's being able to go to places that are really hard to go normally. So here we are at the Lucas Heights reactor, and you go over it and you can start to talk about it. But what the client uses it for is that two-way conversation. So they send someone with a camera and they have a live link. And so normally this video, when they're doing their inspection or that factory acceptance testing, is live, and you can ask the person to put the camera down, to zoom in on an area, to kind of look at a crack or discuss some valves or gauges or things like that. And so everyone, all the experts are back here in Perth, and they have one person over there with the camera. So instead of all the time, all the flights, all the carbon dioxide released in those flights, they save a lot of that stuff by doing a kind of remote site visit.
Wow. Well, that's really interesting. Igloo clearly has a lot of different capabilities for a lot of different businesses. Can you show us what it can do in space?
Sure.
And while he's pulling that up, let's hear from another panelist. David, while James is working on this, can you showcase for us the new technology initiatives that are changing Australia's businesses and how they operate?
Yeah, hi. Thanks, Morgan. Sure. Look, I think many people will be very aware of the obvious ones, such as AI, of course. I mean, you'd have to be living under a rock of late to have not appreciated the explosion, particularly in large language models and generative AI, and how that's starting to access generally everyone, and our ability to start to ask natural language questions of very complex problems and get great answers for that. So, of course, that has profound impact in industry. The industries I particularly work in the resources sector, in starting to assemble really more coherent and exacting answers and well-developed answers across a multitude of different data sources. When I mean that, I mean databases from papers, from drawings, etc., which can really accelerate the decision-making process. And of course, there's the issue of ethics and the regulations behind that to ensure that the information that's being serviced up is good information, and that's very much a work in progress. And you'll see a lot of the regulators starting to become more and more, I guess, concerned as well as proactive in starting to establish the guidelines and the boundaries around which AI can be used. But in an engineering and a if you like, software perspective, the advent of generative AI is huge. The ability to start to more rapidly assemble code, more rapidly assemble design requirements from an engineering perspective, and run simulation and scenarios around that, and put that in a procedural manner, is going to dramatically change the engineering design and research process, the construction process, and also, of course, the software development process, which is really important as well. And AI generally as an optimization task now has been, I guess, being trialled and used in narrow forms really for a decade. A lot of my time was with IBM, and we certainly developed an awful lot of, I guess, the early day developments from Watson, of course, in the world of AI, and being applied to, for example, optimization of processes. That may be milling processes, that might be metallurgical processes, that might be drill, block and blast processes. That could be the actual, a compressor optimization or a well completion or well delivery type process. So there's a broad range at the engineering level, and of course at the enterprise and organizational level, and how we work together. And using automation generally with the advent of AI really starts to optimize that process. So I think we're all clear on the potential of AI. We're still, I think, at a narrow to broad level. Certainly generative AI is starting to move that more into the broad category. In other words, more broadly used, and orchestrating one AI task with another AI task. For example, in a mine, you might have your heavy mobile equipment starting to work together. And that brings us to, how does that happen? Well, I guess there's the advent of edge technology as well, starting to embed greater compute power closer to real processes, means those processes can work in a much more real-time, optimized and intelligent way together. And that's, I guess, the advent of bringing cloud and the compute power of cloud down to really the process. So that's a huge benefit. And I guess that brings us to the other category of digital twins and simulation. Simulation in my day, when I was a young process control engineer, was done very much in very specific processing units, PLCs or advanced process controllers. Now, simulation is done in the cloud or at the edge cloud. And so we're able to create these things called twins, as we all like to call them, which we'll talk about a bit later. But the advent of digital twins with AI, with the compute power of cloud at edge, again, starts to enable us to do many things and simulate many things. With the Igloo is a great example where you're able to create a virtual environment, simulate working in that environment, or maintenance in that environment, or operating in that environment, remove safety, risk, and all the things I'm sure would have been said earlier in terms of that environment. So digital twins from a design perspective, from a simulation perspective, from design, from operations to maintenance and tasks is of course significantly changing that landscape. And so that's not just in engineering. I guess there's the other really interesting area is, how do we start to simulate carbon and carbon liability for twins? So that's another area I think that will take another, I guess, life of its own in terms of emissions management. What bit of equipment or what plant or what operational activity or what bit of power that we're consuming is producing the most or the least emissions? How do we simulate that? How do we feed forward that in time to understand how best we arrange our processes, our physical processes in the plant, in the mine, offshore, subsurface, etc., to minimise the emissions and carbon use, and therefore mitigate carbon liability. So there's a whole range of areas, from the AI, I guess, from narrow to broad to general AI, which is a future position where we're all using AI like we use electricity, to sapient AI, which is of course the matrix really, where we really are introducing robotics now into the world of AI and the compute power into a robotic format, which brings us again to the robotics discussion, which of course we'll probably touch on, I guess, in a later time. There's a couple of other things I wanted to talk about. One was additive printing, or additive printing, 3D printing, I think is again something of a game changer. Not just, you mentioned, I think, the NASA work, but printing on demand tools, printing shapes, printing engineering components. And imagine that printing capability being serviced by a mining metallurgical processing capability right at the coalface, being able to mine, produce the minerals, print those into a format and a tool set will greatly change the way that we can make our mining processes more efficient and really short circuit those value chains to the manufacturing end of the spectrum, and also mitigate and minimise material movements from supply chains, which again means less energy, less material movements, less people movements, less equipment movements. So put that to the moon or put that to Mars, and you've got 3D printing, mining, if you like, in situ mining, and being able to build your tools and build your components and start to assemble your world on the moon. And then with robotics, obviously being able to do those tasks in a highly automated way and in a very intelligent way with AI. So you can imagine all of these things coming together. It's a fairly fantastic space to be operating and a really exciting world ahead for us. One more technology, I think, which we really do need to honour is quantum computing. And again, I think it is starting, again, from my days at IBM, we were, I guess, promoting the benefits, potential future benefits of quantum computing really 10 years ago, or at least 10 years ago. And now the use cases that are being developed, particularly in chemistry, so for example, in new catalysts for chemical making to make plastics renewable or biodegradable or recyclable, in mining, new mineralization species that could create new technology or battery chemistry, and also in cryptology. How do we better improve the way that we're securing our data? Quantum computing can help these challenges significantly, as well as, of course, very, very complex supply chain optimization challenges. So you can see the world of AI, the ability to embed that at edge, the ability to bring cloud and the compute cloud power to edge, automate that through robotics, be able to start to make the material making process much more efficient and circular, reduces emissions, reduces material usage, and makes the ability to start to manufacture much closer to the point of extraction or production, and then being able to create these really interesting new materials through quantum computing and ensuring our data is safe. So I think I'll wrap that up there, but I think that in amongst all of those technologies is a fascinating world ahead, not just in the exploration of our cosmos, but in the really hard problems that relate to building renewable fuels, recycled plastics, new minerals that will be able to be used in a much more profound way, for example, in creating batteries that are better, and so on and so forth.
Wow, thank you so much, David. That is really interesting. You know, I was going to get more into the details about the contracts for Australia's mission to Mars for the moon that they're working on with NASA. But I mean, I think you kind of already went into that. But it's fantastic, some of the work that is going on in Australia to connect Australian mines to the Moon to Mars mission. That is absolutely fascinating.
I think I took it a step beyond where we're at the moment with the Trailblazer and Artemis, but you're right. I mean, I think what you know, the work that, for example, Rio and Woodside, and I think Fugro and Nova Systems, I think, is some of the Trailblazer projects proponents working with NASA are starting at a much more fundamental level in terms of trying to just create, you know, obviously, one, put the rovers, the lunar rover on the moon that Australia's providing to extract oxygen out of the soil. And I think, you know, the intent there is that they'll be able to start to create a processing facility, create oxygen, and start the ability to you know, man the moon, so to speak, and using, of course, autonomy and robotics to do that. And to your point, you know, Woodside have been working with NASA now for 7 or 8 years in terms of you know, removing risk offshore and subsurface, and so has mining. And you mentioned Rio Tinto. You know, they have the largest robot on the planet in their auto haul system, their rail system, and are managing a lot of their automation remotely back in Perth in their remote operations centre. So there's no better examples that are really happening for NASA to refer back into. I was just at NASA on the weekend, actually, but for NASA to refer back into then the work that's happening there, how to control, very complex processes and complex activities and equipment remotely. And so I think, it's an exciting stage that this thing is now starting to materialize. The work is happening to get a lunar rover onto the moon with the Artemis project, and I think 2026 is the intent. And then you've got these great companies who are operating and doing these things, for real on Earth, that we might be able to learn from to help, improve and make more safe the ambitions of building these oxygen areas that we can start to work into to deliver on those other outcomes I mentioned earlier.
Sure. And it's really interesting how this relates to some of the stuff James was talking about earlier, and how Igloo can operate, in Perth for an offshore venture. They can train employees onshore, so they don't have to send everybody off. Imagine the impact that has for the moon too.
Absolutely. Yeah. Well, I mean, you think of the far-ranging use cases. The moon is obviously, that's the moon shot, literally, and metaphorically, but 100%. I mean, you create this virtual environment that is, and which is only improving, of course, in terms of the accuracy by which it actually reflects the real environment, and being able to start to remotely control, robotically control activities that are, from here to the moon. It's just phenomenal. And there's so many other use cases for that as well in healthcare, with surgery, that people in remote areas in third world countries that desperately need healthcare, and something like Igloo or similar, being able to service, operations that just can't be done. So, there's terrific opportunity for those virtual applications.
Fantastic. Thank you, David. So now that we've discussed technology, let's talk about a large global issue, which is keeping this technology cyber safe. Peter, thank you for being here with us today. Can you tell us a little bit about utilizing the cloud and potential risks you see with new technologies such as an Igloo?
Yeah, thanks, Megan. I think any use of data and digital, I think, is incredibly important for organizations kind of in this decade to stay relevant and to continue investment in their digital journey. Obviously, for industrial organizations, and especially as we get into either OT specific concerns, or we're relying on kind of third-party systems like cloud, we've got to ensure that we're managing that risk appropriately. As a security professional, I think it's important for us to enable those secure connectivities and use of cloud, use of digital, use of data, all of the buzzwords. I think it's important to enable those and ensure that we've got that security by design, so that we can leverage the benefits of cloud, so that we can leverage the benefits of technology, the artificial intelligence, all this beautiful AR and VR that can support organizations' cost savings, environmental savings, and better efficiencies through use of technology.
Wonderful, thank you. James, what systems do you guys have in place to keep Igloos secure?
Yeah, it really depends on the client and I guess the level of technology they're working with. Something like this, where it's in the energy sector, it's a real balance between making it accessible and supportable, and then how secure it is. Because I guess you have a lot of different people coming in to do design work, and people that need support in the space. You have all external providers that are providing CAD and BIM models and getting them on the system as well. But then sometimes systems like this are hooked up to the control room, and you can actually see a live digital link to the platforms. And so there is the ability to actually impact a working platform. And so it really depends on the use case as to how secure it is. And normally there's a lot of different layers to get to that point. And so sometimes it's securing it so that there's only video links and they're not connected by IP. Sometimes there's jump boxes and things to get in. And then things like constantly changing passwords, two-factor authentication, and things like that as well.
Fantastic, thank you. Let's talk to the entire group at this point. So where do you guys see robotics and digital twins moving in the future to impact each of your fields? James, would you like to start?
Yeah, I think where a lot of people that get an Igloo tend to have it as a very narrow use case, and they have it for one thing that they plan to use it for, be it digital twins or something like that, or doing training. But what it ends up growing to is the whole life cycle of the project. And it's really interesting to see how something like a digital twin goes from something like the design data to then how that flows on through the use of the project. And so that digital twin that was used to design the plant, something in Navisworks, is what gets used to create the training scenarios. And then all the kind of operational training is done with that Navisworks model. And then that gets moved over to facilities management and how they're using it for that as well. And so it's been interesting to see that things kind of evolve so that the digital twins are not just a very narrow use case now, that the whole, they're from the start of the project to the very, very end of the project.
Okay, great. Peter?
Yeah, I think completely kind of resonate with that experience from James, that they're fantastic use cases that once you've got them in to be able to support that project phase or the build phase or the integration phase, they can add a lot of value to the life of the plant, whether it's onshore, offshore, oil and gas, or energy manufacturing and similar. There's a lot of capabilities. I suppose a lot of people don't know where to start. That's one of the biggest challenges of data and digital, or having that unknown challenge. But sitting down and talking to someone who works in that digital space is incredibly important to be able to unlock and leverage those opportunities that might exist within the existing ecosystem, or maybe within the organization, especially some of these large organizations. Having a chief digitalization officer, we're seeing far more common to be able to connect that tissue and to build the solutions that enable the organization's success.
Great, thank you. David?
Yeah, look, I think, twins combined with robotics is, clearly a big mover and a big changer. And embed AI in that and all the compute power of cloud, then you're able to, and you made the point, you're able to significantly make work in hazardous places much more safe, because you're actually remote from that and in a virtual place being able to extend those tasks. So whether that's offshore on a platform that might be off the northwest shelf, it might be in the North Sea of Scotland, etc., or it might be in the middle of nowhere in a desert somewhere. Of course, that is a great safety improvement. It's also a great benefit to, I guess, the energy dimension. In other words, you don't need to move materials, you don't need to move people. You can do a lot of these things much more efficiently locally. And so, you think about even that applied to exploration. Exploration of minerals is a huge area that we need to do much better and use data and AI much more effectively to be able to explore. So you combine exploration with a digital twin of the geological deposition or the geology, the mineralization quality and quantity, and you can be much more accurate in your drilling and extraction processes. So it's fascinating to think of the opportunities. Of course, the advent of twins through the construction process and engineering construction activities is really taking shape, making the design process much more optimized. You may not want to, you want to make sure that you only use the absolute minimal amount of concrete, for example. Concrete is an expensive material. The mining of it is of course, impactful to the environment, and then the actual concrete making process is heavily energy consumptive. So from a design perspective, you want to absolutely optimize concrete pours, for example. And so having a digital twin of that design, having a digital twin of that construction process, and running scenarios of how much material, where, what's the best design, how should I get that material to that location, how many resources or people do I need to activate that task. Getting that just right has great effects, not only downstream through the construction process to make sure the construction activities are on time and on schedule, but also, and the quality is accurate, but also the upstream sort of, mining to materials movements and supply chain activities that service that. So I think, it's profound. It's of course, as you looked at through the Chevron example, very, very powerful. The advent of robotics into that is also very powerful. For example, I remember with Glencore and Kidd Mine in Ontario, and working with a company called Boston Dynamics, which is now owned by Hitachi. And I think most people have seen Spot the dog, which was one of the early robotic, and still is a great tool, and becoming more and more understood how to use such a tool or robot in mining, for example, where you can put this and deploy this dog-like robot into to create routine mobile tasks in hazardous areas, and of course go 5 kilometers underground. So that's a great advantage, and it itself can look at visual, map things visually, sense vibrations, thermal imaging, speech, and I think now even odor. So you can imagine this robot in hazardous areas that might have gas, in all of the labyrinth of the hundreds of kilometers of tunnels underground, using that to map the underground and understand how best to either create the next part of the mine design or mine and produce is a great exercise. And you have multiple, and to your point about twins and AI and robotics, you have many of these Spot robots working together by virtue of the capability of embedding AI and all of the communications at edge, in other words, close to the mine and mine activities. All of these working together mean that they can start to do orchestrated tasks that people were traditionally doing underground. So I think there's a lot of benefits from 3D measurements that they can take, production data, post-blast and rock face surveys, hazardous areas that they can, robots can get involved in. And of course, the simulation part of that, not just through the design activities and the simulated construction, but also through the operational activities to improve operating efficiently. And as I said earlier, potentially taking that into the world of carbon and carbon liability, mitigating the energy usage, the emissions usage, optimizing the type of power you're using, maximizing your supply chains to be more optimal in terms of movements, picking the right equipment to procure that is low carbon, and it goes on and on and on. So, it's a really exciting world. There's an endless number of use cases. I think the challenge is how do we best apply our limited economics to get the most impact moving forward, and we need to do it really quickly because, of course, a lot of the real challenges are ahead of us to address the climate crisis, and that's looming rapidly. So I think all of these technologies can help greatly in that regard as well.
Absolutely, we think so too. And really, the International Society of Automation is always looking to lift the voice of automation globally, particularly by revealing new ways that technology can work with humans to improve business practices. That's one of the main things that scares people today about automation is the fear of a robot taking over their job. So, that's always a part of our goal. So we appreciate you working with us today to showcase some of the things that Australia particularly is doing to shine a light in the world on those types of things. So thank you for your time today, David.
No problem, Morgan. Just on that last topic, if I may.
Mm-hmm.
I know this, like you say, the automation has been an incredible advent now for over 150 years, and it's spurned the industrial revolution, and now the technology and information revolution, and now AI, of course. Though, I think the reality in all of this is that a lot of these tasks will never be closed loop. Certain physical tasks will be, but a lot of the organisational tasks will always require, the intervention of the specialist, and so I think we'll see, great advances and great integration of these AI automated tasks. I think we'll also see and understand that new, if you like, new roles will emanate from these advanced improvements and optimization of tasks. And when I say new roles, there was a great term that Ginny Rometty, the ex-CEO of IBM, coined, which was, it won't be so much blue collar or white collar, but new collar roles will come from, this hollowing out of the workforce. So you'll have great specialists, you'll have a lot of people, doing key basic foundational elements. You'll have a lot of automation that will remove the broader, if you like, run-of-the-mill activities that a lot of people were doing, but that will create these new collar roles. It will be, absolutely, embedded in technologies. Like most people now can interact with generative AI, whereas 10 years ago, to do that, you would have had to have been either a mathematician, a data scientist, or a computer specialist to be able to leverage AI. Now, everyone can do it. So that brings to bear this notion of new collar roles. So I think it's an exciting future. Yes, there is necessary regulations. There are necessary guidelines to be put in place. There needs to be ethical AI brought to bear, and the understanding of what data can be used for specific reasons to attain objective outcomes and safe outcomes. And I think, there's technologies we spoke about much earlier, all of those combined, AI, quantum computing, obviously the robotics, the simulation, which we've highlighted throughout this podcast, as well as, the additive printing and so on, and what we're seeing. It is exciting. It will require a lot of collective investment, and from an economic as well as from an intellectual standpoint, and the right ethical framework behind these advantages and advancements to get where we need to get to very quickly. So I just wanted to finish on that note, probably, Morgan.
We hope you enjoyed our technology showcase here at Igloo. We are looking to showcase to the world Australia's impact on robotics and digital twins. So we're happy that you are here with us to lift a voice in automation for ISA. Thank you, and we'll see you next time.
This has been Podomation, brought to you by the International Society of Automation. Thanks for listening, and remember to subscribe and review wherever you listen to podcasts. It really helps people to find our content. Podomation is produced by me, Liz Neiman, and Morgan Fora at ISA. Our music is by Mixer Drummer and has been licensed from Pond 5.